Today I'd like to talk to you about online resources for spectroscopy that we're delivering from the Royal Society of Chemistry. There's a lot of spectroscopy on the internet. There's presentations, guidance in the form of tutorials and videos. There's tables of spectral information available. Some pretty neat interactive spectral displays and molecules. You'll see some of those today, I'm sure. Spectral data available for download that you can download to the desktop and display it in your own tools. There's assigned spectra, there's shift tables, vibrational tables, and even some online prediction algorithms, both free and commercial. And RSC is working very hard on supporting spectroscopy to deliver it to the community, so chemists, especially in education, can use it. Some of the resources I'm going to talk about today include ChemSpider, which is a very large database, and at present we have over 3,000 spectra in it. We're going to talk about how ChemSpider serves data up for a game to learn spectroscopy, and SpectraSchool, which is for learning about interpreting spectra, not just NMR, but also infrared, mass spec, etc. And there are more things planned. ChemSpider is at chemspider.com. It's 28 million chemicals, and we have lots of associated data. I won't bore you with all the details of ChemSpider. I encourage you to go test it out. www.chemspider.com. But when you do a search and you come to a record, in this case we've searched on cholesterol and we come to the record, we see the chemical, we see all types of information such as in-sheet strings and names, etc. Part of the information includes spectra. If you look under the spectra tab, you will see spectra that have been linked. And here we see there's HNMR, CNMR, and electron impact mass spec, and if you click, you will see the spectra. Here's an example, fully interactive. This uses the JSpecView applet from Bob Lancashire. We'll be speaking today. You can zoom in. The data commonly are licensed as open data, so that you can use them as you choose, and you can simply download and use the data in lesson plans, presentations in your own database, etc. The spectra come from various sources. We get them from chemical vendors, we get them from scientists who upload them themselves, scientists who've given us collections, private collections of data, and we simply deposit them to ChemSpider. But the majority of data does come from ChemSpider users. It's very simple to upload a spectrum. All you need to do is be a registered user of ChemSpider. You don't have to register to use it, but you do have to register to add data so we know who it's coming from. Simply locate the structure of interest and deposit the spectrum against it by clicking on Add Spectrum. It's a very simple process. This is the type of interface you will see. We support various types of spectroscopy. As you can see, various types of 2D, and those are deposited as images, various types of mass spectral data. Also, we have infrared, Raman, UV vis, etc., etc. So all you do is locate the type of spectrum it is, upload your spectrum file. We prefer JChemP, but we do accept images if necessary, and you add comments and submit. As an example, this is where somebody submitted a new structure. They submitted that through the ChemSpider submission system. Anybody can add data to ChemSpider. And then they added the proton spectra, fully interactive, the carbon spectrum, the COSY spectrum, the HSQC spectrum, and the HMBC spectra. These are all online, all available for people to use. It's a good set of data, this, to learn about how to interpret the spectra and elucidate that structure. There's even an assignment for the full carbon-13 assignment uploaded. This is uploaded as an image and is available on the record. In order to see what spectra we have available, you can go to chemspider.com/spectra.aspx, that URL right there, and it will give you a list of all of the depositions. You can filter by spectral type. You can see what's been uploaded, when it was uploaded, etc., etc. We've also given the ability to embed the data, and by that we mean just like you would embed YouTube videos inside a blog post, for example. You might choose to put together a web page and you might want to use the spectra. All you would do is you would click on embed that comes right adjacent to the spectrum and copy this code right here, and it would show the spectrum inside your blog. We also serve up a wiki called the Learn Chemistry Wiki. We've been working on this now for about a year. It was released earlier this year, and it is a site for educators to access information about chemicals, about tutorials, quizzes, information about substances, etc., etc. So this is the Learn Chemistry Wiki. Here's an example of what you'll see when you take a look at the list of substances. You can actually search all the substances on Learn Chemistry by a structure search, but if you want to look at an alphabetical index, you would simply click on the links. And here's an example of seeing under the letter B the different types of chemicals are available. For as many of these as we can, we've given access to spectral data where possible. All of the data are stored on ChemSpider. Here's an example on Learn Chemistry. The substance is benzophenone. This is a much more stripped down version of ChemSpider. We're serving the data from ChemSpider though. And it says right here, the spectra are available on ChemSpider. You can get the proton NMR, there are 2, carbon NMR. There's actually information on NMR Shift DB, which is an online database of assigned spectra. And there's also information on the SDBS. Probably you can check on that, and it will show you. If you want to add spectra, we point you to ChemSpider to do so. And here you are going straight through from the Learn Chemistry Wiki out to ChemSpider, and we're showing you the spectra. This data was submitted by Khalid Mirza from Drexel University, so submitted by one of our users. So where did the data come from? Again, ChemSpider users are commonly depositing the data, so if any of you have data that you're generating and you wish to share it with the community, we would love to receive it. You can put your name against it. You can keep the data yourself, of course. You're not transferring the rights to those data to us. You can keep copies yourself, but we would like to share them to the community. We've also had some contributions from NIST, which we thank them for, and increasingly chemical vendors are starting to provide data. One of our most recent depositions, a few hundred spectra, came from Synthonics, and we're very grateful to the work they've done to generate those data for us. By building web services, which is a programming interface against ChemSpider, we've provided a way for people to access the data. By doing so, Jean-Claude Bradley and Andy Lang have been able to build a SpectralGame. You can access it at spectralgame.com. This is where you can come and learn about how to interpret spectral data. It's a matching game. We display a spectrum and a couple of structures initially, and we say which one of these best matches the spectrum. So is it likely, without having aromatic protons, nothing down around 7 ppm, is it likely it's this compound? No. So you would select this structure and it would give you a score and take you to the next spectrum. After 10 of these pairs, then it moves into 3 structures, and then it gets increasingly complex to 4 structures and 5 structures, and then you have a time limit. It's a great way of learning the spectra. Also, as a side effect of using the game, we look at the data regarding how people have played it, and we can actually find errors by looking at how the game is played. The game is available but playing in the hand, so you can play it on an iPhone or an iPad, and we're very grateful that we've been able to work with the ChemDoodle group to get their web components. Fully supports the JCam Spectra in ChemSpider that we use in JSpecView, and also has a beautiful viewing interface for the spectra here. Learn Chemistry also has a tool that allows you to learn a lot more about spectroscopy. In this case, what we have is a library of chemical compounds, and for each of them we have proton, carbon, infrared, mass spec, and UV spectra. And you have the ability to select from the library the compound, in this case benzaldehyde, and you can see the carbon spectrum here, the infrared spectrum, and the mass spectrum. And I could of course show you the proton and the mass spectrum also. But this allows you to browse what the spectra would look like and learn about fragmentation and assignment, etc. We have some videos on here telling you how the spectra run for each of the analytical techniques. So these videos will play, and we are updating these videos, doing some work with Cardiff University. There's also a set of tables, essentially electronic tables, telling you where particular types of proton would resonate. Show you here the chemical shifts for the various types of protons, and also the various shift ranges you would get for particular carbon environments. So you could look at these types of helper tables. And we also see little helper tools here where we're showing the ranges. As you hover over, it will actually tell you what type of chemical shifts you're looking at. We also have an identify mode, which is like a test. So it gives you information about a particular sample and then gives you the spectral data, but it doesn't tell you what the molecule is. So you have to figure out from the clue and from the spectral data what the compound is. In this case, we've got a colorless to water white liquid with an acetone-like odor. The spectral data are here, and the data can be collectively interpreted in order to identify that the compound would be pentan-2-one, as shown here, and with some of the properties, and also there's a link into the ChemSpider database. What we've been working on of late, and just recently released, is working with ACT Labs to plug in an HTML5 widget. What does that mean? It means this will also work on iPad and iPhone, modern browsers. And what we've been working on is the display of assignments. So this is an experimental spectrum that has been assigned, and you can see here when we hover over this multiplet, it shows us what the assignments would be on the molecule. This is brand new. The spectra presently being assigned en masse and are being rolled out. We've started with proton NMR and carbon NMR. We will be extending this in the next few months to infrared, vibrational assignments, mass spec, fragment assignments, etc., etc. So this is brand new work that we've just started to unveil on SpectraSchool under Learn Chemistry. What we have coming soon is we will be adding thousands of infrared spectra to the collection on ChemSpider, so they will be available. They will also feed into other parts of the system, such as Learn Chemistry, and as well as hopefully extending the SpectralGame over the next few months. It would be great to see whether or not we could add infrared interpretation, etc., etc. We're also going to add tens of thousands of mass spectra, and we really encourage you to submit your data to ChemSpider if you would. Please feel free to contact us at ChemSpider and discuss with us whether you have collections, and we can probably use that as a batch collection to deposit. While I'm giving the talk, and actually I'm doing this remotely on a movie, of course, there's a big group of people who've been involved in bringing together the multiple resources that are presented in this presentation. There's an entire team of people that have supported this work, connecting us to the right sources of information. The RSC education team have been very critical in helping to support this work. The University of Leicester developed the first version of SpectraSchool that has been online for a couple of years and have worked with us to make sure that we can migrate it in-house. Jean-Claude Bradley, Andrew Lang, Robert Lancashire and Kevin Thiessen have been responsible for working on the SpectralGame. Kevin Thiessen's group with ChemDoodle has been critical in making it available with the modern widgets. Gary Allred and Chi Wang at Synthonics have helped provide the data, and the people we've been working with at ACT Labs have been Ryan Sasaki, Sergey Glotvin and Pranas Yapatas, and we're really grateful to the fact that they've been able to help us squeeze in a lot of functionality in order to be here and show you what's underway at present, and of course the deposit of data, and there are many people depositing data. Thank you for attention. I hope this has shown you a good overview of what we've been doing with spectral data, spectroscopy resources at Royal Society of Chemistry, and we encourage you to use them, give us feedback, and I think you will see a lot more coming in the future months in terms of analytical data hosted by the Royal Society of Chemistry. Thank you.